Okay, so we have 5 questions from this page to go over. All right, maybe they're a little bit, a couple of them might be a little bit more difficult than the others, but hopefully you did okay. So number 1, a physics student with too much free time drops a watermelon from the roof of a building. He hears the sound of the watermelon going splat 2.5 seconds later. Knowing that the speed of sound in air is a constant and is 340 meters per second, how high is the building? So the first part of that you have to do is, what are the 2 parts to the question? Well, part 1 is the watermelon falling, and part 2 is the sound coming back up. Okay, so, sorry, just trying to find the edge of my page here. There we go. So for number 1, we have the watermelon, and we have the sound. Okay, so it says a student drops a watermelon, which means VI is 0. From the edge of a building, he hears the sound. Okay, so he's dropping it, so A is 9.81 meters per second squared, and that'll be down. And for the sound, it says the speed of sound is constant, and in this case it's 340 meters per second. Speed of sound is always constant in a given medium, but it's dependent on the temperature. When it's air, it's dependent upon the temperature, so that's why I'm giving you the 340. Now, we don't know the delta D for the watermelon, or T for the watermelon. We also don't know the delta D for the watermelon. We don't know the delta T for the sound, and it's different than the watermelon, because the watermelon falls down, and then the sound travels up. What we do know is that the delta T of the watermelon plus the delta T of the sound has to equal 2.5 seconds. So the delta T of the sound is going to be 2.5 seconds minus the delta T of the watermelon. And hopefully that makes sense to you. Okay, now what about the delta D of the watermelon and the delta D of the sound? Well, however far the watermelon falls from you, that's how far the sound needs to come back. So the delta D of the watermelon is equal to the delta D of the sound. So we can write an expression for delta D of the watermelon. I'm just going to do it down here because I don't have enough space up there. It should be VI delta T 1/2 A delta T squared, where this goes to 0. So delta D of the watermelon is equal to 1/2 A delta T of the watermelon squared. Delta D of the sound, we should be able to use our VAV equals delta D over delta T equation and get the delta D of the sound to equal the VAV times the delta T of the sound. But the delta T of the sound is equal to something in terms of the watermelon. Okay, so we know our delta D of the watermelon equals our delta D of the sound. So where our delta D of the watermelon is, I can fill this in. And so it'll become 1/2 A delta T of the watermelon squared. And where the delta D of the sound is, I can fill this in, so it's equal to VAV delta T of the sound. Now, notice the 2 times aren't the same. So where this time is, I have to sub in the 2.5 minus the delta T of the sound, of the watermelon. Okay, so 1/2 A delta T of the watermelon squared is going to equal VAV brackets 2.5 seconds minus delta T of the watermelon. Okay, so now I only have the unknown, the delta T of the watermelon. Multiply through by the bracket, 1/2 A delta T of the watermelon squared will equal VAV times 2.5 seconds minus VAV times delta T of the watermelon. Whoops, and that bracket can go. Or I can put it on both sides, I guess. Okay, but now look, we want to solve for delta T of the watermelon. And it's going to be a quadratic because I have a squared term, a single term, and a whole number term. So bring everything over to one side. 1/2 a delta t of the watermelon squared plus v-av delta t of the watermelon minus v-av times 2.5 seconds equals 0. It's now in that ax squared plus bx plus c form. Okay, we could fill our numbers in before we do the quadratic. So 1/2 9.81 meters per second squared, t squared, plus 340 meters per second, delta t, and these are watermelon t's, minus 340 meters per second times 2.5 seconds equals 0. Half of 9.81, 4.905 meters per second squared, t squared. So that's my A term, plus 340 meters per second, delta t, my B term. 2.5 times 340, 850, I think 680, and yeah, 850 meters per second times seconds meters, my C term. Okay, so if you want to write it on the side to make it clear for you, so A is 4.905 meters per second squared, B is 340 meters per second, C is negative 850 meters, and you're going to use delta t of the watermelon is equal to, remember the quadratic, negative b plus or minus square root b squared minus 4ac all over 2a. So negative b, so negative 340 meters per second, plus or minus square root 340 meters per second squared minus 4a, 4.905 meters per second squared times c, negative 850 meters, all divided by 2 times 4.905 meters per second squared. Delta t of the watermelon equals, so this is negative 340 meters per second plus or minus. On the bottom it's going to be 9.81 meters per second squared, and under the root, before you take the square root, it's 13277 meters squared per second squared. Move this sheet out of the way so I don't end up writing on it. So negative 340 meters per second plus or minus, when you take the square root of that, it's 363.699, I think, meters per second over 9.81 meters per second squared. So you're going to get two possible answers. You're going to get negative 340 meters per second plus 363.699 meters per second over 9.81 meters per second squared, or you're going to get negative 340 meters per second minus 363.699 meters per second over 9.81 meters per second squared. Clearly this one's going to give you a negative answer, and time can't be negative. So it has to be this top one. So what do you get? It's 23.699 divided by 9.81. 2.416 seconds is your time. If you did this one, you got negative 71.73 seconds. Okay, so that's the time for the watermelon. The question asks, how high is the building? So now you need to go back to your watermelon equation and fill it in. So delta D of the watermelon is equal to 1/2 9.81 meters per second squared times that 2.416 seconds squared. Okay, and so delta D of the watermelon will equal 28.626 meters